Hi, I'm going to show you how to install and run AWS load balancing extension of Apache Stratos. So let's take a quick look at my setup. So I have a Stratos server running in one of my EC2 instance, and I have a separate instance for message broker, and I have a EC2 instance for a sample PHP application that I have already deployed here. So let's go to the console and let's try to install the extension. To install the extension, you need a zip file or Apache Stratos AWS extension. You can find it in a Apache Stratos distribution, or you can also build it from the source. So once you have the zip file, you need to unzip it. Yeah, we are done with unzipping. So let's just cd into the directory. So you can see there are different folders like bin, config, lib, and there are different files like install md and read md. So before even installing the extension, we need to make changes into few configuration files. These configuration files are present in current folder. So let's just cd into it. So there are different files like AWS properties, JNDI properties, log4j properties, and thread client config XML. First of all, we will edit the AWS properties. Right. So it has values like access key, secret key. These are related to AWS, and we need these to access the AWS API to create and manage load balancers. Then we have load balancer prefix. This is the prefix that is used while creating a name for the load balancer. So we generate a unique sequence numbers and we just append those sequence number to this prefix to create name for load balancer. Then we have security group name. This is the security group name which is associated with the load balancer in order to allow or restrict access to that load balancer. Then we have allow CID IP. This is the range of IPs by which you can access the load balancers that gets created. Then we have allowed protocols. You can specify here protocols like TCP, UDP by which you can access the load balancer. Then we have statistics interval. It's in second and it should be multiple of 60, and this is used to gather the statistics related to load balancer like request and response, and it's used to calculate the in-flight request count, which is then sent to CEP. So I'll keep all these values default and I'll just fill in access key and secret key. Okay, now I've filled in those values for access key and secret key in AWS properties file. Now let's just edit JNDI properties. Here you can see there is a entry for Java naming provider URL, and this URL should point to message broker IP and the port 61616. And my message broker is running in EC2 instance, this one, and its IP is this. Let me just copy that IP here, copy that, I will save it. Then we don't need to make any change in log4j properties. Now we'll edit the thread client config file. Here the IP should point to a IP of the machine where CEP is running. In my case, CEP is running on Stratos server itself, so I will put this IP there. I will just save it. Okay, now I have filled all the configurations needed to start the extension. Before starting the extension, let me show you the AWS console where we can see the load balancers. So if I reload the page, you can see that there are no any currently load balancers created here. And also, if we have specified a security group name, which is the default ones, LB security group, there is no any security group here with name LB security group. So this will get created when create the first load balancer. Okay, so let's just start the extension now. To start the extension, we have a file AWS extension.sh. We just need to run it as a super user. Okay, now the extension is started. Now it will wait for the topology event to receive, and Then accordingly it will create load balancer and configure them. So we have an application deployed here, PHP application, and we have an instance here which is associated with that application. So it will create a new load balancer and attach this instance to that load balancer. So we will just wait for a few seconds. Okay, now the AWS extension is reconfigured. Yeah, here you can see it is now creating load balancer LB1, as it is the first load balancer that has been created. The sequence number that was entered is 1, and it has been attached to the load balancer prefix that we mentioned in AWS properties file. So it has created the load balancer, and this is the DNS name of that load balancer, and it has also attached the instance to that load balancer. So this instance name is same as this one, and now the AWS extension has been started. So now you can see the load balancer is created on the AWS console. Yeah, and it has attached the instance. The instance is still out of service. It will take some time to register it to the load balancer and be in service. So we just wait for a few seconds. And we need a security group for the load balancer that is also created here. You can see, yeah, and it has added an inbound rule to the security group based on the port mappings used for the cartridge. So here the inbound rule is the allowed protocol is TCP, the port range is 8480, and the source is 0000. This is also be specified in the AWS properties file. So we are allowing access to this load balancer from any IP. And you can see here the port configuration of load balancer is 8480. That means any traffic that comes to load balancer at port 8480 is forwarded to port 80 of the instances attached to those load balancer. So we need the incoming traffic for the load balancer 8480. That is why we have inbound rule for security group 8480 port, and the protocol is TCP. Now let's just see if the instance is in service. Now it is still in out of service. We'll wait for a few seconds. So this, I'll tell you from where this 8480 is coming up. If you look at the application, this application has a PHP cartridge. So if you go to the PHP cartridge, port mappings are proxy port 8480 and the port is 80. This is the port of instance and this is the port of load balancer, and we are using protocol HTTP. That's why the port configuration of load balancer has to be 8480 of the load balancer port and forwarding to port 80 of the instance, and the protocol is HTTP. So this is the explanation of why this port configuration is like this. So let's just take a quick look. Yeah, now the instance is in service. Now you can access the port 80 of the instance using the port 8480 of the load balancer. So let's just hit the URL. Yeah, you can see that this is the application that is running on an instance at port 80, and using the port 8480 of the load balancer we are able to access that application of the instance. Now If I undeploy an application, this load balancer will get deleted. Similarly, if I shut down the extension forcefully, then also this load balancer will get deleted. So let's just try shutting down the extension. Yeah, now you can see, yeah, it is deleting the load balancer LB1. So if you just reload the page, the load balancer is now deleted. Similarly, the same thing will happen if I undeploy the application. So that's it. Thank you for watching.